In this video we're going to look at the final value theorem. Now the idea behind this is that we can find what happens to a function in the time domain as t tends towards infinity, and we can find that in the complex frequency domain. This value is given by how the frequency in the complex frequency, the function in the complex frequency domain behaves at the origin. So let's start off, and what we're interested in then is if we take our function g of s, function in the complex frequency domain, and we take the limit as s tends towards 0. So we're interested in what happens to the complex frequency function at the origin. So we'll get that as s tends towards 0. So we're interested in, then if we write this out, it'll be the limit as s tends to 0 of the integral from 0 to infinity over function g of t e to the minus st by dt. So that there then, as s tends towards 0, e to minus st will tend towards 1. So that integral there will then tend towards the integral from 0 to infinity of g of t by dt. Now what we're interested in again isn't the function g of t, we're interested in a function f derivative of t. Okay, so what we're going to do is we're going to look at the integral from 0 to infinity of a function f derivative of t by dt, and we know that's going to equal the limit as s tends towards 0 of, now the derivative of the Laplace transform of a derivative is going to be given by this s f of s. Again, we've derived that before, and that's minus our f of 0. Okay, so in this instance here then, this here, the integral of the derivative, will just give us the limit as t tends towards infinity of a function f of t minus a value f of 0, and that's going to equal the right hand side, which is a limit as s tends towards 0 over s f of s minus f of 0. Okay, so what we can do is we can cancel our f of 0's, and we left with our final value theorem, which really tells us that if we take the limit as t tends to infinity of our function of time, so we can tell what happens with our function of time as t tends towards infinity, and we can tell that by taking the limit as s tends towards 0 of our function s f of s. Okay, so that there is our final value theorem. Okay, now again, best done by example. If we take the same examples we used in the previous initial value theorem, if we say f of s equals 1 upon s minus a, say a is less than 0, then we can find out what the behaviour of the function of time is as time tends towards infinity. If we find out the limit as t tends to infinity over function f of t is going to equal, well, it will be the limit as s tends towards 0 over function 1 upon s minus a times the value s. So we're just going to be s upon s minus a. Okay, now we can see there as s tends towards 0, this entire function here tends towards 0. Okay, so it means that our function there, which we looked at in the previous video, again 1 upon s minus a equals e to the at now u of t. Okay, so as value for t tends towards infinity, then this function here is going to tend towards 0. Okay, so that there is our final value theorem, and just like the initial value theorem, it tells us how we can find out what the value for the time domain function is as t tends towards infinity, without having to do any inverse transforms of this frequency domain function. Okay, so thank you for listening and goodbye.